Welcome to the video, Business Statistics, Chapter 6, Continuous Random Variables, presented by the University of Akron College of Business Administration, Department of Management. Let's take a look at what exactly we mean by continuous random variable. As just a refresher, in the previous chapter, Chapter 5, we looked at discrete random variables. And if you remember, the characteristic of a discrete random variable is that each experiment or each trial can only have a finite number of outcomes. For example, rolling a six-sided die, one roll may result in a 1, rolling the die may result in a 2, and so forth, all the way up to 6. And we say this is a discrete output because it has to be a 1, or it has to be a 2, or it has to be a 3. There can't be any values in between. In contrast to that, this chapter is all about continuous random variables, and the hallmark characteristic of that is that it's a measurement of something and it can have infinitely many values. As such, it will always fall on a number line. So let me illustrate that here by drawing a number line that represents temperature in degrees Celsius. Let's say that we measure the current temperature and decide that measure that it's 5 degrees. If we take another measurement, maybe 6 degrees. If we're able to more precisely measure, we may be able to say that it's 5.605 degrees, and so on. So there can be an infinite number of values that a continuous variable can take. Let's now look at the characteristics of a continuous probability distribution. A continuous probability distribution always can be represented as a mathematical function, f of x, for example. And let's draw a continuous distribution here. I'll use the example of a normally distributed function. So we'll draw our number line down here. I'll just label this as x, and I'll draw what we call the density curve above that line. So here we're looking at a normal distribution. And several characteristics will always hold true for any continuous distribution. Let's think of the entire area under this f of x curve as being equal to 100% of all area. So in that case, three common configurations that we'll run into when working with continuous random distributions are a scenario, let's just say that x represents the height measurement of a person in feet and inches. We may want to calculate the probability of a randomly selected individual from this data that may fall in a range of 5'4" to 5'6". In that case, what we will do is calculate the exact amount of area that that range takes up out of this 100%, and that will then correspond to the probability of a random individual from this data having a height that falls in this range. Two other configurations that will be encountered will be a certain value and everything below that value, or one specific value and every value that falls above that value. And we'll continue with this chapter in the next video. Let's take a look at several specific tools or types of distributions. Thanks for watching.